Today we're turning code into cloud, and we're going to show you how to use Terraform to provision your full AWS infrastructure, setting the stage for Ansible to take over next. This is the second step in our DevOps in Practice series, and here you'll see real Terraform in action. EC2 instances, security groups, and full validation via ping and SSH. This is where real DevOps begins, infrastructure as code ready for automation. And leading this hands-on session is our expert from the Cloud Bootcamp, Herbert Pereira.
Welcome back. And in this video, we're going to provision AWS resources using Terraform. We will create and access a new directory. Also create a main configuration file where we will have the Terraform code, which will create our EC2 instances and a security group. First step, let's create a directory. If we list it now, we have a new directory created. I'm exactly inside the directory we just created, and we have our main file. So let's open and access this file. From within this main file, we'll need to make one important change here, which is to put the ID of the default security group that has been associated with our EC2 workstation instance, so that we can make sure that the machines that will be created are properly allowed to communicate directly with our workstation, since our main goal here is to create our machines that will be part of our Ansible inventory. But first, let's install a useful extension so that we can better visualize and work with the Terraform code. To do this, click here on Extensions and search for HashiCorp Terraform. Install this helpful extension for better syntax highlighting. After installing this extension, you'll see that your Terraform code here will look much better. Well, that said, now let's get to our actual code. Here are some of Terraform's main code blocks, and we're going to explain each one. The first block is the provider configuration block. It covers which specific region we want to deploy to. We have no authentication information precisely because we have configured an instance profile for EC2. The EC2 workstation already has the permissions to create resources on AWS. And as I'm running inside this machine will carry out the creation process with the permissions it has. And here we'll be creating two machines, host 01 with the Debian operating system and host 02 with the Red Hat operating system. Let's take a look at the code here. Here I have the image ID of Debian version 12. It's going to be a T2 micro machine. I'm using the same VS Code SSH key. And here I'm making the association with the security group that will be created automatically. A security group will be created to associate with this specific instance, and the security group will have a specific rule there to allow access to the security group of our EC2 workstation instance. So our workstation has its permissions, so we'll allow this communication, and here we have a provisioner which executes commands locally. This command will collect the public key and add it to the file of known hosts. It will avoid that verification prompt the first time you connect to SSH. If you remember, as we made the connection here, we marked Linux, then had to give a confirmation. So to avoid this step of being asked for information, the public key will already be inside the hosts, which will help us when we run the Ansible communication process with these machines. And the name of this machine will be host 01 Debian. Likewise, the same code, the same block of code will be used to create host 02 Red Hat. The difference here is the image ID, which will be different, obviously, and the name of the machine, which will change. In addition, we're going to create this security group, which is exactly what we see associated as the TCB security group ID. Terraform handles this intelligently. It knows that it will first have to create this security group and then associate it with the host, because it can't associate an object that doesn't exist. So the object needs to exist first. So this new TCB security group will be created, where it will have specific permissions on port 22 SSH and port 80 HTTP. And in addition, there will be an association with our TCB workstation security group. So if we head back to the console, we can check and validate this ID configured here. Let's return to our EC2 workstation instance and scroll down slightly. We'll notice the same ID of the default security group displayed right here under the security section. Back to the code, and here we have the communication firewall rules. This one means for any port, any protocol. So, communication between the EC2 workstation and our two inventory host instances that will be created will be complete and unrestricted. And in order to properly configure the inventory file, we need to know the private IP address of each of our server instances. Ansible's communication with these machines is obviously private by design, so we need to have these specific private IP addresses to configure in our inventory file, right? Well, that being said, now let's go back to our terminal. And now we're ready to run the Terraform commands. Let's start here by running the Terraform init command, which is the command that does the downloading process, the provider's plugins. In this case, it will be the AWS plugin. It will go to the HashiCorp repository and download the AWS plugin. Great, you've downloaded the plugin. Now let's move on to our next important step, which is Terraform validate, where it carefully validates whether there are any syntax problems in our code. In fact, we only have one main code here, but this command is very interesting because it validates whether the syntax is okay. What's more, if your code is a bit messy, it can also be used with Terraform format to properly format your code. Here we have the Terraform plan command, which shows what is planned to be provisioned in the next process step, the actual deployment process. So it shows here that exactly 3 resources are going to be created. Why 3 resources? Because there are 2 EC2 instances and 1 security group. Once this is done, we can clear the screen and execute the next command that will carry out the deployment process, which is precisely the Terraform apply command. I'm setting this auto approve flag here so that I don't have to type yes and confirm that I want to create these resources. Process completed. If we go back to our console and look at the instances, we'll see that we now have not only TCB Workstation, as well as 2 other EC2 host instances that are exactly the machines that will be part of our inventory, which will be managed with Ansible. So we've successfully deployed everything using Terraform, and now we're moving on to the next steps, which involve configuring these 2 EC2 host instances as the inventory so that Ansible can properly manage them. We will need to copy these EC2 host instances IP addresses from the Terraform output result, since we'll be using them in the upcoming configurations, okay? Once we have the private IPs, we will move on to our next step, which will be the communication test. So let's go ahead and perform 2 different types of communication tests, starting with a ping test and then an SSH test. We carry out these communication tests to ensure that the workstation where Ansible will run establishes full connectivity with the target EC2 machines across our environment. So it's better to guarantee this than to have problems there with Ansible. So first step, I'm going to ping the host 01 machine. So we did. We can see that it's working perfectly. I'm going to ping the host 02 now. It's communicating via ping. We know that ping uses the ICMP protocol. Now we need to ensure that there is also SSH communication working properly, because Ansible communicates with these inventories via SSH communication. Ansible is agentless. You don't need to install anything, you just need the communication. So to do this, we need the SSH private key file to perform an SSH communication test. So I'll select my SSH VS Code key PEM file and upload it to this workstation machine. And we can do this in a very simple way. Just select the SSH private key file and drag it into the VS Code on the Terraform folder. So it'll be copied inside that folder. Once we've done that, if we list it again, we'll see that we now have the private SSH key file, right? We need to adjust the permissions of this private SSH key file, which is easily done with this command. Great. Having done that, we now move on to the SSH connection test process. Remember that we have one machine that is Debian and the other is Red Hat. To access Debian, the user is admin. So I'll pass SSH, pass my key, pass the admin user, and the private IP of this machine, and test the SSH connection. Great. A successful connection means that our workstation machine is able to communicate with the Debian machine. Let's log out of the Debian host instance. Let me clear the screen, and now let's initiate the connection process with the machine running the Red Hat operating system, following the same steps but changing the user to EC2 user. If the connection is successful, we can also validate the operating system that is running, which is Red Hat. Let's leave this screen and come back here, remembering that I'm here on my workstation machine. Wonderful. And that concludes this part. We provisioned our infrastructure using Terraform and ran connection tests, both with ping and SSH. We're ready for our next step in the part of our next video which is going to be configuration with Ansible. We're going to create a host file and do all the preparation so that Ansible can manage and install Apache on these machines. See you in the next video.
All right, thank you so much for watching this video. And then if you enjoyed this content, please consider subscribing to our channel. Give us a thumbs up if you enjoyed this content, and then also please leave us a comment telling us what you think about this video and also the things that you'd like to see in a new video here on our channel, okay? And then if you're interested in mastering Move to Cloud, DevOps, and AI with our help, please check the links in the description as well. Hope to see you in the next video. Take care and goodbye for now.